Alright, so welcome to this brief video on cost curves. We're going to go through 4 topics. All of these are somewhat different from what will be presented in section and a lot different from what's presented in the book. So think of this as a supplementary video, or sorry, a supplement. It's not a replacement for section or for reading the book, both of which are critically important. And the main goal is that I'm going to go over briefly some definitions of different types of cost curves, but then spend most of the rest of the time talking about the main kind of mistakes or misunderstandings people have about these cost curves, and how can you think about the cost curves in a way that's going to help you most efficiently answer questions and solve problems. And a lot of this is basically just sort of how to think about the math, because all of this is math. It's all geometry and algebra and numbers, but how can you think about it and relate it easily to the economics and use it to solve problems. So we'll start with some definitions. FC stands for fixed cost. You need to memorize this. Your fixed cost is always just going to be a number. It might be 0. Yeah, there might be no fixed cost. But if you see an equation and you just see a number that has no Q, no quantity attached to it or anything, like 25, that's your fixed cost. If you graph a fixed cost, it's just a straight line. If you make 1 unit, the fixed cost is 25. If you make 0 units, it's 25. If you make 50 units, it's 25. So fixed cost, not so interesting because it's just a number. It's a little different from all the other curves. VC is your variable cost. This is anything that's not a fixed cost. So if you're building stuff at a factory, you might have a fixed cost of you had to pay $1,000 to rent the space or to build the building, but anything like the wages you pay your workers, the money you spend buying steel, the electricity you pay to run the plant, all of these are variable. The more you use the plant, the more people you hire, the more steel you buy, the more you pay. TC stands for total cost. Total cost is just the sum of variable and fixed costs. Those are the only 2 types of cost you'll have in any equation. And then we get to these, the same letters except with an A prefix. The A in each of these cases stands for average. So this is average fixed cost. So average FC. And as you can probably guess, you're averaging relative to the number of things produced, which we always know with either a big or lowercase q. Often for a single firm it will be lowercase q. So AFC is just FC divided by q. You can then infer that average variable cost is going to be VC divided by q, and average total cost is TC divided by q. None of these are that difficult to understand. FC, VC, and TC very intuitive, and then AFC, ABC, and ATC are just the above divided by q, average over q. So at this point, we have one more definition, and then I want you to do problem number 1 and 2 on the associated worksheet. There's a link to it below the video. It's also on the website. It's really important that you stop the video at this point and do those practice problems, because those are the skills you're going to need to use to, to solve problems on the problem set and especially on the test. So our last definition is marginal cost. So this M stands for marginal. And as you remember from Greg's first lecture, hopefully, marginal refers to like 1 more or 1 less. So your marginal cost is how much your total cost changes when you add 1 more, when you produce 1 more unit. For our purposes, though, we might not tell you exactly how much the total cost changes when you make 1 more unit. We might only show you how much it changes when you make 2 more units. So you'll divide the change in total cost by the change in quantity. Most of the time, that denominator, that change in quantity, is just going to be 1. But don't forget, if we change it by 10 units, you have to divide the change in total cost by 10. You might be wondering why we have a second equation. Is this really the same thing? Isn't there a difference between total cost and variable costs? And the answer is when you look at the change in variable costs, or the change in total cost, they're always the same. Total costs only change when variable costs change. So the fixed cost is fixed, so it doesn't change at all. So the change in total cost or the change in variable cost divided by the change in Q will both give you the marginal cost. So you sort of have 2 methods, but it should make a lot of intuitive sense to you. Think about this until it makes intuitive sense why you can use either or. So now pause the video, do worksheets number 1 and 2. The answers are on the website. The problems are not that difficult, but they give you critical skills that you're going to need to use throughout this entire unit. So it's very important you stop and do those now. I'm waiting. Okay, and we're back. So moving on. The important thing you need to understand, and that really the biggest thing people struggle with throughout this entire unit, is that cost curves are functions. Cost curves are functions. The ATC, the average total cost, is not a number. It's not something where you say the ATC is 5 and the price is 5, so they match. Saying the ATC is 5 is sort of meaningless. You can only have the ATC as 5 when Q is equal to 1. So you write it as a function just like f of x. ATC as a function of Q equals, say 10 over Q plus Q, say. It's meaningless to say the ATC is a number because you really need to know what the Q is. So you want to think of the cost curve, the ATC curve, or the ABC curve, or the TC curve. All of these are functions that you're graphing, and they all depend on Q, so you can't talk about what the ATC is or the VC is without referring to what the Q is that you're calculating the costs of. The only exception is fixed costs. Those are always the same, doesn't matter what Q is, although in principle it's still a function. So with this in mind, let's think about how we graph these babies. First of all, we can graph them all on the same graph. So a lot of the time people ask, what is this vertical axis? And the answer is it's like any kind of cost. As long as all the curves you're graphing have the same units, you can graph them all together against each other. We saw this with how you can graph price, marginal, private benefit, marginal social cost. All of them have the same units of dollars per thing, or dollars per unit, dollars per pound. So you can graph them all together on the same axes. It's the same with any kind of cost. All costs are measured as dollars per unit, with the one exception of fixed cost. So, all the average costs and the marginal costs are in dollars per unit. So you can graph ATC, ABC, AFC, average fixed cost, marginal cost. You can graph all of them together. So let's do an example. Maybe we have a marginal cost that looks like this. We have an average fixed cost that looks like this. Average fixed cost is never going to increase. And then we could have an ATC that looks like this, maybe, and you can graph them all together at once. But the most important thing to think about when you're graphing these is that they're not numbers, right? They're functions. We're graphing a function. It might look sort of like a U, like ATC does, or a different sort of shaped U that's bent more strongly like MC, or it might just be decreasing the whole time like AFC. But when we ask you what is the ATC, usually we mean what is like the entire function. In rare instances, we might say what is the ATC and mean like what is the ATC at this particular point. But then you need to have in mind that we have a particular Q that ATC is associated with. The same way, if we said demand, we really are typically referring to the entire demand curve, although on some occasions when we're being sloppy, we might be talking about the quantity demanded at a particular point, but there's always a price associated with that. All right. So this brings us to the main thing you're going to need to use throughout this entire unit to solve problems. You'll always be given some type of condition. Technically, it's either an optimality condition or an equilibrium condition, but you don't really need to be able to distinguish the two. You just need to know that there's going to be some conditions. And these conditions, just like QD equals QS, will tell you what equation to set up or what curves to look for intersecting on the graph. That'll tell you what's happening in the market. So if we give you curves, if we give you geometry, the conditions tell you which 2 curves to look for crossing. If we give you equations, then we're asking you to look for where 2 functions are equal. And either way, they're going to give you some kind of Q. your answer is always going to be some number q that makes this condition true. Sometimes people mistake a condition, like for instance in our example below, the condition will be p equals mc, and they think that this is a definition, like that the price and marginal cost are defined to be equal to each other. In math, if you want to show two things are equal, you actually use a different symbol than equal sign. You use this equals with 3 dashes like this. But we don't use that symbol here because these things are not defined to be equal to each other. We're looking for a point, a particular q, where they happen to be equal to each other. So geometrically, let's draw that in. If we have our cost on the on the vertical axis and we have our q on the horizontal axis, we might have p equals 6. So it looks like this when we graph it, and we have mc equals 1/2 q. So that's like an upward sloping line. So this is mc, this is p. And we're basically asking what is the q when these two intersect? So we're asking what is this number? Now obviously this number is really tough to find with a graph. You probably aren't going to be doing it with a graph, getting an exact number. But maybe the number is already written on the graph for you. Like maybe the number is here like 12. I think the answer is 12. And then you can just sort of read the graph. Where is p equal mc? It is only true at this particular point where q is 12. It's not a definition like the two are actually always equal to each other. Now, alternatively, and sort of the better and easier way to do this is with equations. So we have p equals 6, mc is 1/2 q, and now you can see the same thing. We're using this condition not as a definition, we're using it as a way to find q. So we solve for q and get, just like on the graph, we get q equals 12. So now if you understand this process, you'll basically at this point, it's going to be real important to stop the video, and I want you to do worksheet problem number 3. Problem number 3 is long because it's the main technique you'll use for this unit. If you can do the problems in worksheet on problem number 3 on the worksheet, then you've basically been able to solve all the problems throughout the unit. You've learned all the math and sort of all the problem-solving skills you'll need for the entire firm behavior unit, except for one lecture at the very end. And now all you'll have to do is sort of learn the economics behind what all those symbols mean. But functionally on the test, understanding the math is really going to be more important for your grade than understanding the economics. So I highly recommend you stop the video and do problem number 3 on the worksheet, and then check your work answers are posted online. All right, so finally, there's one last important point about drawing these graphs. For the most part, the curves aren't really that closely related to each other. As you might have guessed, average total cost is the sum of average variable and average fixed cost. So in principle, when you add the AFC's height and the ABC's height, it should add up to average total cost. But we're not going to nitpick about that because we don't really care if things are drawn to scale. We will nitpick about one particular relationship among the curves, and it is the relationship between marginal cost and average total cost. And then similarly, there's an identical relationship between marginal cost and average variable cost. So let's imagine that we have a team, like a group of people, like a basketball team, and we add one more person to the group. And we can measure that person's height, that's the marginal height we're adding to the group, and say that person's 7 feet tall. And then we want to compare that to the average of the group before we added that person, before we added that 7-footer. And let's say the average height was 6'2". Well, when we add that 7-foot person, he's going to pull the average up. So in a marginal cost or marginal person, marginal anything that's added to a group with a lower average, so that's the second case here, that means it's going to pull it up. So the average will increase. So when you have MC above ATC, that means ATC is increasing. So being pulled up by all these marginal guys with high costs. The reverse is also possible, so I want you to walk yourself through that now. Like pause the video and think through why does when MC is less than ATC, you're going to have ATC decreasing. As you add those guys with low marginal cost, what's going to happen to the average total cost? And similarly, the rule is the same for ABC. Okay, great. And you're back. So what does this have to look like on the graph? Well, it means that if MC is above ATC, we've got to show ATC going down. So if we have sorry, I might have said that wrong. We have MC below ATC, we need to show ATC going down. So let me draw in my MC. And then let's say ATC starts here. Well, MC is below ATC, so I need to have ATC start out going down. And then maybe I have ATC over here. I might have this point. And now MC is above ATC, so I need to show ATC going up. And so the interesting thing is, as long as ATC keeps going and MC is below it, I'm going to get pulled down more and more and more, until I get to a point where they're equal to each other, where they cross, they intersect, they're equal. All of these are saying the same things. There's a special Q where MC equals ATC. Only at that special Q. You can find it with the graph by going down and noting this point on the horizontal axis, or you can, most likely this is what you'd be doing, using the equations to find that point. And now that you've found it, what's going to happen to the ATC curve at this point where they're equal? Well, it's not less than, it's not greater than, so it can't be going up or down, it can't be increasing or decreasing. It just sort of doesn't change at all. It just stays flat. And then once you cross that point, now MC is above ATC again, so it's got to be pulled up. So the lesson is that MC equals ATC. It's always at a minimum or a maximum. For our purposes, it's the minimum. ATC will always have a minimum. Basically, never in any of our graphs have a maximum, although in principle it could. So MC will equal ATC at ATC's minimum. You need to know this relationship. It is critically important. You need to know that there's something wrong with the graph if the ATC is decreasing when MC is above it. You need to know there's something wrong with the graph where the ATC's minimum is not where MC is intersecting it. It means that the ATC is not increasing when MC is above it. Otherwise, it could have gone to a minimum where they're not crossing. So I want you to do worksheets 4 and 5. They're both a little tricky. They basically ask you to identify what's wrong with these cost curves, and you're supposed to use just the lesson from that previous page. So finally, we'll summarize what we've learned today. There's some definitions of cost curves. They're incredibly intuitive. You need to memorize them. The only one that's a little tricky or new for you is the marginal cost, but it's related to some concepts we've been studying all throughout the course up till now, so it shouldn't be too difficult. The second and third concepts are the most important. Cost curves are functions. When we say P equals MC, MR equals MC, we're not saying that these are the identical curves. We're not saying they're identical concepts. They're totally distinct. They'll just happen to intersect at one point, and what we're really asking you to do is find that point. Use the equation, set them equal, and find that Q, or look at the graph and look for where they intersect. Once you can do that, all you'll need to know is what conditions to use for each problem, and we'll prepare some great worksheets to help you memorize that. You'll have like 3 or 4 weeks to do it, so it'll be pretty easy. And then finally, there's an important relationship between ATC and MC, and there's the same relationship between ABC and MC, and that's that ATC is minimized where it intersects MC. If MC is above ATC, then ATC should be increasing. If MC is below ATC, then the marginal costs are low, they're pulling the average down, so you should see ATC decreasing. Thanks for watching this video, thanks for doing the worksheet. I feel like you're going to do great on the next test if you master especially these 2 skills right in the middle, using optimality and equilibrium conditions and graphing and understanding and interpreting cost curves. Thank you.